Hello everyone, I am Urvashi Vikranta, pursuing PhD in Food Technology from Department of Dairy Science and Food Technology, Institute of Agricultural Sciences, Banaras Hindu University. Today I will be discussing about electronic nose. Before starting, a question come to our mind is why there is a need of electronic nose. So in daily life, the human nose is a useful analytical tool to evaluate the quality of foods before consuming and identifying potentially hazardous gas present in the environment. With the development of society, the importance of olfactory application in food industry, environmental detection and medical treatment is increasing. The human nose has around 400 scent receptors and can detect at least 1 trillion odors. Although the human nose can rate a smell based on individual's judgment, and this may be biased. The human nose cannot be used to sense toxic gases. In addition, human nose has detection limits for different gases. Those limitations prevent the human nose from being a universal tool for all smell related discrimination and classification. So, electronic nose is a gas sensor array that gives fingerprint response to specific volatiles, which then can be used by pattern recognition algorithms such as artificial neural networks to perform discrimination and classification. So, there is correlation between human olfaction with artificial olfaction. The similarity of electronic nose with the biological sense of smell can be observed in the smelling process. The first step in both is the interaction between volatile compounds, usually a complex mixture, with the appropriate receptors, that is, olfactory receptors in the biological nose and a sensor array in the case of electronic nose. The next step is the storage of the signal generated by the receptors in the brain or in a pattern recognition database, that is learning stage, and later the identification of one of the odors stored is the classification stage. An electronic nose uses currently a number of individual sensors, typically 5 to 100, whose selectivities towards different molecules overlap. The response from a chemical sensor is usually measured as the change of some physical parameters, that is conductivity or current. So this is the diagram of typical e-nose system in which there is a physical part. The physical part of a typical e-nose system that consists of gas sensor arrays, reaction chamber, valves, air pumps for sampling and cleaning, then the control devices and data acquisition devices. An electronic nose generally consists of an aroma extraction system, a sensor array, a control and a measurement system, as well as a pattern recognition method. An aroma delivery system which transfers the volatile aromatic molecules from the source material to the sensor array system. Then comes the reaction chamber where sensors are installed. This has usually fixed temperature and humidity, which otherwise would affect the aroma molecules absorption. The electronic transistor which converts the chemical signal into an electrical signal, then amplifies it and conditions it. There is a digital converter that converts the signal from electrical to digital, and there is a computer microprocessor which reads the digital signal and displays the output, after which the statistical analysis for the sample classification or recognition is done. Then there are some sensors present in e-nose. Depending on the sensing material, gas sensors can be classified into several types, including conducting polymers, metal oxide semiconductors, quartz crystal microbalance, surface acoustic wave sensors. The target gas react with sensing material causing reversible electrical properties such as conductivity. The measurement of conductivity is typically obtained by measuring the output voltage of the sensor and characterizes the output voltage pattern by parameters such as voltage peak, response time and recovery time. Some working components of electronic nose are, which I have already discussed. This is sample delivery system, detecting system, computing system. Then data analysis for electronic nose. Digital output generated by electronic nose sensor has to be analyzed and interpreted in order to provide information. There are three main types of commercially available techniques, that are graphical analysis, multivariate data analysis, network analysis. Then sensing, interpreting, discriminating process of an electronic nose. Electronic nose is a technology to explore biological olfactory system. The electronic nose can analyze gaseous sample, more specifically volatile compounds. The sensing, interpreting, discriminating process of an electronic nose is a mimic of human olfaction. Typically, the volatile molecules react with sensing materials of the gas sensor and cause irreversible changes in electrical related properties. These changes are then detected and characterized by pattern recognition algorithms to perform the discrimination and classification. This is the block diagram of an eNose system, which consists of synthetic air cylinder, blower, air inlet valve, closed sample container, sample, volatiles, sampling valve, sensor array chamber, data processing and pattern recognition, purge valve and purge outlet. So what are the functions of eNose? Primarily, the electronic nose has great application value in the identification of odor such as wine, vegetables, etc. It is widely used in odor detection, raw material inspection, quality signing and sprinkling process management. It is one of the indispensable tool for quality assurance and quality control. The electronic nose is mainly used for quality evaluation, maturity detection, and species identification in different fruits and vegetables. Secondly, in terms of medical diagnosis, the electronic nose is a cutting edge diagnostic method for early detection of diseases. So talking about the application of eNose in food industry, that is spoilage examination in food. So spoilage can occur in either stages of slaughtering or harvesting, cleaning, blanching, processing, packaging and storage, as well as handling and distribution. In recent decades, some diagnostic tools such as electronic noses, electronic tongues and biosensors have attracted much interest in food spoilage detection and could be considered as a potential alternative for detection of food spoilage. Then in milk and dairy products, some studies that have focused on the feasibility of electronic nose in evaluating the shelf life of several dairy products, including yogurts, cheese. An electronic device, eNose device named AFOX 4000 electronic nose equipped with 18 sensors and an auto sampler was used to evaluate the growth of total bacteria in milk stored at ambient temperature of 5 degrees centigrade. The results showed that measurements generated by electronic nose could be used to detect both bacterial growth in milk as well as shelf life of the milk. So in meat products, the electronic nose results were compared with those obtained by microbiological sensory and headspace GC analysis. The eNose could clearly distinguish broiler chicken packages with deterioration from fresh packages either earlier or at the same time that sensory changes indicate significant deterioration. Now talking about the food quality related properties determination using ENOS. So quality evaluation is a challenging concern to ensure the maximum level of food safety since it is one of the important key attributes in determining consumer preference. However, until today, suppliers and retailers are still relying on the traditional methods which are labor skill intensive, subjective and mostly destructive. The potential and ability of an electronic nose application as a monitoring device in quality evaluation of agricultural and food products are known. The ENOS technique can be very useful in analysis of volatile compounds of grain and dairy products for monitoring food quality. Some researchers studied the fish freshness using ENOS sensor based on the day of packaging and after the expiration date. The fish samples were determined using total viable count and achieved higher than 84% classification rate according to the microbial contamination. So, application of ENOS for agricultural food products and food quality evaluation. Being a fast detection technique, the ENOS devices are able to contribute greatly to the numerous applications involving quality assessment of agricultural and food products. Some researchers reported the application of an ENOS device equipped with fuzzy logic to classify guava samples during pre-packaging. The classification accuracy obtained from the fuzzy logic component achieved 90% accuracy based on the pattern recognition tool used in real-time condition. Talking about the benefits of ENOS for detection of adulteration. So the risk of high value food adulteration with cheaper substitutes has reached an alarming stage in recent years. Commonly available detection methods for food adulteration are costly, time consuming and requires high degree of technical expertise. However, a rapid and a suitable detection method for possible adulteration is being evolved to tackle the aforesaid issues. In recent years, electronic nose system is being evolved for falsification detection of food products with reliable and rapid way. Electronic nose has the ability to artificially perceive aroma and distinguish them. So, a recent investigation on adulteration detection of pure cow ghee with sunflower oil and cow body fat was studied using a device name 8 MOS sensor based ENOS system. Honey can be adulterated with cheaper substitutes such as water, syrups, and inverted sugars by fraudsters for their financial gain. The gas chromatography based ENOS technique was used by researchers for corn syrup and rice syrup adulteration discrimination in honey. These are some other applications of ENOS. Now, the advantages of ENOS compared with sensory panels, ENOS are less biased and give more consistent measurements between devices. Therefore, ENOS have a broad application in monitoring smell related processing, including cocoa bean, tea fermentation, cocoa or coffee bean roasting, and chocolate conching time. E-noses can also be used to determine the smell related quality of food, such as the varieties of vinegar and freshness of meat as well as meat spoilage. A commercial e-nose is typically handy and compact. Now, concluding these slides, e-nose combining pattern recognition algorithms are very powerful analytical tools which are relatively low cost, rapid, and accurate. E-nose is also suitable for both inline and offline measurements, which are very useful in monitoring food processing and detecting the end product quality. The user of e-nose as well as e-tongue need to strictly control sample preparation, sampling, and data processing. Now these are the references, and thank you.